Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these functions using product rule. So as per the problem, determine the value of dy over dx for the given value of x. So let's start with the first function on the left side. So y equals parentheses 2 plus 7x parentheses x minus 3, and the given value of x is 2. Now for this function, we can find the derivative by distributing the terms in the parentheses using the FOIL method and combining the like terms, and then find the derivative of the resulting expression. Or we can use the product rule by keeping the function in this form, in this factored form. So in this video, we'll use the product rule to find the derivative. So as per the product rule, so the derivative, so here we'll use the Leibniz notation. So dy over dx is equal to the first function, which is 2 plus 7x times the derivative of the second function, which will be 1 minus 0. So the derivative of x is 1 as per the power rule, and 3 is a constant, so its derivative is 0. Then plus, now we have to find the derivative of the first function, which is 2 plus 7x. So the derivative will be 0 plus 7. So 2 is a constant, so the derivative is 0. And for 7x, we have to use the constant product rule. So the derivative is 7 times the derivative of, the second function, x minus 3. Now we can sub in x as 2. So we do not have to simplify this expression before we sub in x as 2. So we can sub in x as 2 in this step to find the value of dy over dx at x equals 2. So this way we'll save some time and steps. So we get 2 plus 7 times 2, and then parentheses, so 1 minus 0 is equal to 1, and then plus, so 0 plus 7 is 7, and then we do 2 minus 3. Now we have to evaluate this expression. So dy over dx equals, so first in the first parentheses we'll do 7 times 2, which is 14, so 2 plus 14, and then times 1, which won't change anything, and then plus 7, and then parentheses negative 1. So 2 minus 3 is equal to negative 1. So dy over dx equals, so now we can add 2 and 14 in the first parentheses, so we get 16. And then 7 times negative 1 is negative 7. So the final answer is dy over dx equals 9. So this should be the final answer for the first function. Now we can analyze the second given function. So the second given function is a product of two functions. The first function is 1 minus 2x, and the second one is 1 plus 2x. So we can use the product rule. So as per the Leibniz notation, so dy over dx will be equal to the first function, which is 1 minus 2x, times the derivative of the second function, which will be 0 plus 2, and then plus the derivative of the first function, which will be 0 minus 2, because 1 is a constant, so the derivative of 1 is equal to 0, and for 2x the derivative will be just 2 as per the power rule, then times the second function, 1 plus 2x. Now we can sub in x as 1 over 2, so we don't have to simplify this expression before we sub in x as 1 over 2. So we get dy over dx equals, So in the first parentheses, we get 1 minus 2 times 1 over 2. And now in the second parentheses, we can add 0 plus 2, which is equal to just 2, and then plus. Now we can combine 0 and negative 2, which is equal to negative 2, and times 1 plus, and now we can sub in x as 1 over 2. Now we can simplify it further. So dy over dx equals, now in the first parentheses, 2 times 1 over 2 is equal to 1. So we get 1 minus 1 times 2 plus, so negative 2. And now in this last parentheses, so 2 times half is 1. So we get 1 plus 1. Now in the first parentheses, 1 minus 1 is equal to 0. So 0 times 2 will be equal to 0 plus then negative 2 times 2. So 0 will go away. So we'll be left with just dy over dx equals negative 4. So this should be the final answer for the second function. So these are the steps you have to keep in mind to solve a problem like this one. So here we use the product rule to find the derivative for both functions, and we sub in x as 2 without simplifying the expression for dy over dx, because that will save time and steps to find the final answer. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.